Have you ever wondered what that ln button on your calculator does? Well, I'm I'm going to show you now. So you don't have to wonder anymore. So what is a natural logarithm? Well, this ln thing means a natural logarithm. I don't know why the n comes after the l. I don't know. Okay, I just looked it up and apparently the number one result says that nobody knows what ln is supposed to mean. Well, that's helpful. So a natural logarithm basically works exactly the same as a regular logarithm. So if you don't know what regular logarithms are, I do have a video on that you can watch on the card on the screen. So if you want, you can watch that and then come back here. So a natural logarithm is basically just a regular logarithm, except that it has a certain base, and that is base e. So what on earth is the letter e? Well, normally in math, when you have a letter, that means that you don't know what the number is. But this is actually not one of those cases. We do know exactly what E is. E works basically the same way as pi. Whenever you see pi, you know that it's equal to a specific number. It's equal to 3.14159 and so on. E is another one of those weird random numbers. E is about 2.71828 and it just goes on infinitely in like infinite digits. People use E in math for like the growth of populations or things like that, or at least that's according to what I just Googled. But yeah, it's not important. All you need to know is that ln is the same thing as log base e. So whenever you see ln, just translate that in your mind, or you can write it down. It's the same thing as log base e. So now that we know this, let's go ahead and do our problem, which in this case is just to turn this into exponential form. So remember that the definition of a log is just what exponent do you have to put on the small number to get the big number. So let's go ahead and write that out as an equation. It's saying what exponent do we have to put on e? We have to put some exponent here, and then we're going to end up with the big number, which is 8. And in this case, it's saying that the solution, the answer to our log is x. So the exponent that we have to put on e is x, and then that gives us 8. So if you think about it logically just like that, what a log even is, then that's how you turn it into exponential form. So ln of 8 equals x is the same thing as e to the x is equal to 8. Now we can actually do this the other way as well. We can take our exponential equation and turn it into a logarithmic one. So remember that because we have e as our base here, this is going to be our small number. That means we can write it as log base e, and this will eventually turn into ln. So it's what exponent do we have to put on the small number to get the big number? And in this case, the big number is going to be y, because that's what we have here. We have y. We don't have a number here. And the answer to the log is always the exponent that you have to put on it. And in this case, the exponent is 5. So what this is saying is you have to put an exponent of 5 on our small number e to get the big number y. So e to the 5th equals y is the same thing as log base e of y is equal to 5. Now in my last video, I talked about properties of logarithms. So if you haven't watched that, you can watch that as well. But you can actually do the same thing with natural logs because they're just the same thing as normal logs, just with base e. Remember that properties of logs you can only do, like combining logs, for example, if they're the same base. But every single ln is the same base because they're all base e. So we can do these same properties with this, and our goal here is going to be to simplify this down as much as possible. Now, eventually, I want to add these two logs together because if you add logs, you multiply the insides. But we can't actually do that right now because we have this 2 in the way, and this 2 is being multiplied because there's no sign. But if you remember back from the power rule, we can actually do this. So let's say we had log base 3 of 5 to the 2, for example. If you have an exponent inside of the log, then you can move the exponent out to the front of the log, and it becomes 2 times this, and we get rid of the exponent. But this actually works the other way as well. If we have a number out on the front, we can move it back as an exponent. So instead of 2 ln of 4, we can turn this into ln of 4 to the power of 2. And we can actually simplify this again. 4 to the power of 2, well, that's 4 squared. And 4 times 4 is 16. So this turns into ln of 16. And now we just have two ln's, or log base e's, that we can add together. Now remember that when you have two logs and you're adding them, then that means you multiply what's on the inside of the logs. So we can combine these into one log, one ln. but we multiply the insides. So 16 times 3 is 48. And that's as much as we can really simplify it. So this is our final answer. Or if you wanted, you could put this into your calculator, but it's going to give you like a super random number. Looks like the natural log of 48 is 3.87, about that much. So this could be your answer as well. So now you know what a natural logarithm is and how you can combine them and do stuff with them. But combining logs and doing stuff with them is also how you solve logarithmic equations, which is like when you have x inside of a log and you need to solve for x. So if you want to learn how to do that, you can watch this video right here. And as always, if you have any questions about this video, go ahead and leave it in the comments and I'll be sure to answer your question. Thanks for watching.